So another previous competitive exam question. The question is, one linear network is connected with two sources. One is V1 source, another is V2 source, and one resistor is connected. This is acts as a load. In load branch, the current through the load branch is I is there. So this is one complete given network. But in this network, elements are not given here, but he mentioned like this linear network. Linear network means internally the usual elements are linear elements, resistor, inductor and capacitor, these elements only. So the complete network is a linear network. This linear network is excited by the two sources, one is V1 source, another is V2 source. Then the current through the resistance means load branch is I here. So I and some given parameters are there. Those parameters are, if V1 is 2 volts, this voltage is 2 volts and V2 is 0, this is 0 volts, then the current through this resistance is 5 amps here. And similarly, if V1 is 0 volts, this is 0 and V2 is 5 volts, then the current through this branch is minus 1 amps. Then V1 and V2, V1 is 10 volts is connected and V2 is minus 5 volts is connected, then what is the current through I here? So this is a complete question. Here, to find the unknown parameter from this problem, from this given network, mesh analysis, node analysis are not applicable, not suitable here. Because to apply the mesh analysis and node analysis, there we required individual loops, number of individual loops, number of principal nodes. That means the complete network elements are required. But according to the given problem, the network elements are not there. Just he mentioned, it's a linear network. So to find the unknown parameter from the given analysis, from the given parameters, so here superposition theorem is the best technique. Because just observe the given problem. So in this problem he mentioned V1 is 2 volts. That means here V1 source is connected, V2 is 0. That means V2 is eliminated. So at a time only one source is connected. One source is connected, V1 source is connected, then the response of the circuit is 5 amperes. So indirectly mentioned individual responses. So V1 is connected and V2 is 0 means V2 is eliminated, only V1 is connected, the response through this one is 5 amperes. So individual response, one individual response is there. And similarly V1 is 0 volts means V1 is eliminated here. V1 is 0 is nothing but the source is eliminated. So now V1 is eliminated, V2 is applied, V2 is here how much? 5 volts is applied, then the response is minus 1 amperes. So with the first source the response is 5 amperes. With the second source the response is minus 1 amperes. If these two are directly connected, total response is equal to sum of individual responses. So from that here I am writing directly, if V1 is 2 volts, and V2 is 5 volts, these two are directly connected. V1 is 2 volts and V2 5 volts, both are connected at the same time. Then the total current is equal to sum of individual responses. This is acts as a I dash and this acts as a I double dash. Sum of individual responses, one response is 5 amperes plus another response is minus 1 ampere, then directly it gives the answer is 4 amps here. Answer is 4 amps if V1 and V2 are, V1 is 2 volts and V2 is 5 volts. But according to the given problem, here V1 is 10 volts is there and V1 is 5, V2 is minus 5 volts is there. Different sources are there, different values are there. Different magnitudes are mentioned here. So with the different magnitudes there, then we have to find out the response here. So to find these type of analysis purpose, another theorem is used. The theorem is homogeneity theorem. Homogeneity theorem. Generally in superposition theorem, indirectly we have to apply sometimes homogeneity theorem. Homogeneity theorem explains any linear network is connected with single source. Any linear network is connected with single source. So this is applicable if it is connected with single source. Single source is applicable here. Any linear network is connected with single source, then right here, any linear network is connected with single source if the source is multiplies with any constants, if the source is multiplies with any constant, multiplies with any constant, then the response is also multiplies with same constant, and the response is also multiplies with the same constant. So homogeneity theorem explains, if the network is connected with only one source, if any network is connected with only one source, if any constant is multiplied with the source, same constant is multiplied with the response. So this is explained from homogeneity theorem. If any constant is multiplied with the source, that means sources increases or decreases, automatically the response of the circuit is also increases or decreases. That is depends on the multiplied constant parameter. So now here I am applying indirectly homogeneity theorem. So to apply that purpose, initially I am taking this condition. This condition, everything I am writing as one table, V1 and V2 and here I. The complete analysis I am writing within table here. V1, V2. So sources are V1 source and V2 sources, response is I. So initially I am assuming this condition, V1 is applied 2 volts, V2 is not applied means V2 is disconnected, V2 is eliminated. So V2 is eliminated, only V1 is connected, that voltage is here, 2 voltage source. What is the response? 5 amps. So this is the 5 amps here. So 2 volt source is connected and V2 is disconnected, then the response is 5 amperes. Now the network is connected with how many number of sources? Only one source. One source is connected, other source is eliminated. So now we can apply this homogeneity theorem. According to homogeneity theorem, any constant is multiplied with the source, same constant is multiplied with the response also. So now according to the given problem here, V1 is 10 volts is connected, then I am replacing this V1 is 10 volts now. V1 is 10 volts. 2 volt source is replaced with 10 volt source. Then how many times it is increased? 5 times. So 2 into 5 is 10. So 10. So 2 volt source is replaced with 10 volt source. Then the input voltage, input source is multiplied with 5. 2 into 5 is 10. Then the response is also multiplied with 5. Then it becomes 25 amperes. Then the response is also multiplied with 5. According to the homogeneity theorem, if the source is multiplied with any constant, then the response is also multiplied with the same constant. Here V2 is disconnected, V1 is applied. Initially the V1 is 2 volts is there, then the response is 5 amperes. And if this 2 volts is replaced with 10 volts, that means 5 times it is increases. Response of the circuit is also increased by 5 times. So 5 into 5 becomes here 25 amperes. So this is the first condition. Then second condition I am taking now. Second condition here, V1 is 0 volts, means V1 is disconnected. V1 is disconnected, which source is applied now? V2 is applied. V2 is how much? 5 volts. So V1 is 0 volts and V2 is 5 volts. Then the response is minus 1 amps. See, in this case only one source is connected. V2 is 5 volts. Only one source is connected. The source is V2 source. V2 source is connected. V1 is disconnected. Now the network is connected with single source. So network is connected with single source. If source is multiplied with any constant. So now according to the given problem, V2 is minus 5 volts is there. Then I am replacing this 5 volts with minus 5 volts without this source. The 0 source is not applying. V1 is not connected. But V2 initially 5 volts is there, the response is minus 1 amps here. And if V2 is replaced with minus 5 volts, 5 volts is replaced with minus 5 volts, then the number of times multiplication factor is minus 1. 5 into minus 1 is minus 1 5 volts. If any constant is multiplied with the source, same constant is multiplied with the response. So minus 1 into minus 1 becomes here 1 amps here. So this gives the second individual response. Now from the given data, I wrote here another data according to the homogeneity theorem. First initially due to 2 volts response is 5 amperes. Now the 2 volts is replaces with a 10 volt source, then the response becomes here 25 amperes. This is one individual response. And another individual response is with minus 5 volt source, the response becomes here 1 ampere. So this is second individual response. Now both are connected. V1 is 10 volts and V2 is minus 5 volts. V1 is 10 volts, 10 volts is connected, and V2 is minus 5 volts is connected. Both the sources are connected to the given network. So two sources are activated. Then we require the total response. From the superposition theorem, total response is equal to sum of individual response. Sum of individual response, one is 25 amperes and another is 1 ampere, then it becomes 26 amperes. So according to the given problem, the answer is 26 amps here. The answer is 26 amps here. So according to the given problem, if V1 is 10 volts, V1 is 10 volts and V2 is minus 5 volts, then what is I? So if both the sources are activated with the different values, one is 10 volts, another is minus 5 volts, then the response is 26 amperes. So indirectly here we applied homogeneity theorem and superposition theorem. Sometimes superposition theorem requires internally homogeneity theorem. This is also one of the theorem. So here homogeneity theorem states that if the network, any network is connected with only single source, if the network is connected with single source, any constant multiplies with the source, same constant is multiplied with response. That is explained by homogeneity theorem. So homogeneity theorem and superposition theorem, directly I wrote answer is 26 amperes. To solve these type of problems, compulsory we have to apply superposition theorem only here, because other techniques are not suitable to find this unknown parameter. Mesh analysis is not suitable here, node analysis is also not suitable. So this is the importance of the superposition theorem. So note on the solution. See one more problem from the superposition theorem. This is previous competitive exam question. The question is like this: two sources are connected, V1 and V2 sources are connected, and the current through the resistor R is I, and some given parameters are given here. So those parameters are like this: the power dissipation in resistor R, the power dissipation in resistor R is P1 due to V1 source, and due to V1 source means V2 is 0, means V2 is disconnected, only V1 is applied. So one source is activated, the power dissipation in the resistor is P1. So this is one given parameter, and power dissipation in resistor R is P2. This is P2 due to V2 source, means V2 is activated, V1 is eliminated. So V1 is 0. If V1 is eliminated and V2 is activated, this also comes under individual response. Then if both the sources are activated, now both are activated, V1 and V2 are activated, then the power dissipation in the resistor R is. So from the superposition theorem explains the total response is equal to sum of individual responses. So at a time only one source is activated, V1 source is activated, power is P1, and V2 source is activated, power is P2. Then immediately we can write the total power is sum of individual powers P1 plus P2. But this is wrong. This is wrong because superposition theorem is not applicable to determine power. To determine voltage and to determine current, superposition theorem is applicable. It is not applicable to determine the power. So don't apply superposition theorem for power measurements. Don't write this answer. This is completely wrong, is it? So don't write this relation P is equal to P1 plus P2. It's not suitable here. Superposition theorem is not applicable. But superposition theorem is applicable to determine current or voltages. So from this analysis, first I want to find out individually currents. From that currents we can find power. But don't write directly these type of equations. So limitations of superposition theorem is it is not applicable to determine power. So power measurement purpose it is not suitable. So but here given question power is given. So to find that power purpose here initially I am taking current representation. So generally power equation is I square into R. I square into R. So I want to find out I here. So to find that purpose initially I am assuming V1 is activated. V1 is activated. If V1 is activated, V2 is eliminated. V2 is eliminated means now V2 becomes 0. V2 becomes 0. If V1 is activated, the current through the resistor R is current through the resistor R. Current through the resistor R is, I am assuming here I1. Current through the resistor R is I1, and according to the given problem, power is how much? P1 is there. Power is P1. P1 watts. Power is P1 watts. Then I am assuming at that position current through the circuit R is I1 I am assuming. So according to the standard equation, P1 is equal to I1 square into R. I1 square into R. Then I1 square is equal to P1 by R. P1 by R. Then immediately I am writing I1. I1 is square root of P1 by R. This is one individual response. I1 is square root of P1 by R. Similarly, I am applying a second source. V2 is activated now. V2 is activated. V2 is activated, V1 should be 0. So V1 is 0, V2 is activated, then the current through the circuit is I2 and power is P2. Just I am assuming the parameters. According to the given problem here, P2 is there. Then from that here I am assuming at that point current through the resistor is I2. So from this equation directly I am writing now I2 is equal to, again we have to write same equation, P2 is equal to I2 square into R, then the I2 is equal to square root of P2 by R. So individual currents are there. One is I1, another is I2. Due to V1 source I1 and due to V2 source I2. From the superposition theorem, total response is equal to sum of individual responses. Now I am taking those individual responses are current parameters. So current parameters I is equal to I1 plus I2. Superposition theorem is applicable here. But this statement is not suitable for power. So don't write this statement here. Then I am writing I is equal to I1 plus I2. Then I1 is here, root P1 by R is there. I2 is root P2 by R is there. Substitute those equations. So this is equal to root P1 by R plus root P2 by R. So finally we get total current. But according to the given problem, the question is find out the total power. So due to these two sources, if V1 and V2 are activated, power is total power P. So V1 and V2 are activated, the power of the resistor is I square into R. Total current square into R. So finally we got here total current. Substitute the complete equation here. So then it gives the root, individual I am writing here, root P1 by root R plus root P2 by root R. See here we can write plus or minus also because depends on the direction. Here I wrote I1 plus I2. If both the currents are in same direction, it performs the addition operation. If the directions are opposite direction, then it performs the subtraction operation. So here we can write a plus or minus representation. Anyone we can write here. So otherwise we can write with plus only. So root P1 by root R plus or minus root P2 by root R. This is total current equation. Square into R. So here root R is there and root R is there. Take it outside. So then I am writing here 1 by root R is outside. Take it common. If it is common, then the remaining parameter is plus or minus root P1 plus or minus root P2 whole square into R. If you apply square operation for this one, R get cancels. Then the total power due to both the sources, total power is equal to root P1 plus or minus root P2. Here also you have to write plus or minus whole square. This is one standard equation. So this is one of the very important here. If V1 source, only one source is activated, the power dissipation in one resistor is P1. If the second source is activated, the power dissipation in the resistor is P2. If both the sources are acted now, then the total power is equal to plus or minus root P1 plus or minus root P2 whole square. This is another standard equation, and after simplification becomes here P1 root P1 whole square is P1 plus P2 plus or minus, depends on the plus minus, because A plus B whole square formula I am applying here. A plus B whole square or A minus B whole square. A square plus B square plus 2AB or minus 2AB. So plus or minus root P1 into root P2. So you can write either this equation or this equation. So this is another standard formula to measure the power to measure the power with individual sources. So then the total power is equal to square root of P1 first source due to first source response plus or minus square root of P2 due to second source response whole square. So this is another standard formula to measure, to determine power of the given circuit. So please note it down.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SAIMEDHA.in app. If you open the app guys, you are going to see there. Let's talk about the store now. In some other branch, let's open a EEE branch guys. In the EEE branch you can see the content. In the content engineering, in the engineering we have electrical circuit 75 videos there. In that machine nodal analysis, if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3 questions with solution, previous ecet questions with solutions, and at last we have what machine and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys. Based upon the topic marks, it is going to be there in the not only in ecet but also in the government jobs and PSUs. And at last you have there an online test examination also, in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ecet examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys for EC, EEE and civil, this SSC JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board Junior Engineer and as well as ISRO guys. If you people are interested to watch all the full length videos in the SAIMEDHA.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486925998. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material, and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.